Okay, we're going to start off with some steps. This would pick up the pace here. So step number 1 is going to be to isolate the radical on one side. So when we're solving radical equations, step number 1 is to isolate the radical on one side. Now, tomorrow we'll start dealing with two radicals, but right now we're just going to have one radical, so you're going to isolate it on one side. Another way I could say that is you want to get the radical by itself. Then you're going to raise each side of the equation to the same power to eliminate the radical. Raise each side of the equation to the same power to eliminate the radical. And the power will equal the index. Raise each side of the equation, because we know by this point that what you do to one side of the equation, you have to do to the other. And you're doing that to eliminate the radical, because radicals and exponents are opposites of each other. So you're going to raise each side to some power to eliminate it. That power has to match the index. And then the third step is you're going to solve the equation, and then you have to check. Now, we've all been around and thinking back to, junior high when we first started solving equations. It was always solve and check your answer, solve and check your answer. At that time, you were solving and checking to see if you had done anything wrong. Well, that's always a good idea, first of all, but we get to the point that we feel pretty confident and we don't check, and I'm guilty of it too. And if we make a mistake, we chalk it up. I made a mistake on that one. Well, we're going to get to a point tomorrow where you have to check, because there's something called extraneous solutions. Does that word sound at all familiar to you? Absolutely?
No, it's absolutely not. That's
okay. I didn't think that we had talked about it in here. So we'll talk about it tomorrow. But because these things exist, it's not going to be that we did anything wrong. It's going to be that, it's a special kind of answer, and we have to check to see whether it works. But we're not going to get to them today. It's going to be something we get to tomorrow. So today we won't officially have to check. It will be more, just solve an equation like normal. We'll get to the checking tomorrow. Very good.
Mm-hmm.
All right. So here we go. Square root of 2x equals 4. Square root of 2x equals 4. So the radical has to be on a side by itself. Is the radical by itself? Yeah, the radical's over here. It's a square root. Well, the opposite of a square root is going to be to square it. So I'm using an exponent of 2. Well, that means on this side I have to use an exponent of 2. And that's because that index is 2. The power, the exponent, thanks, Maddie. The exponent matches the index, and I do it on both sides. So the radical and the exponent cancel each other out. You just get the radical, and you can give it to Mrs. Picture. Thanks. And so we get 2x equals, and then here's what we're going to forget. We probably won't forget it today, but once we start mixing these up on the Chapter 6 review, we'll forget. This is 4 squared, not 4 times 2. It's 4 squared, so it's 16. But once we start mixing these up, you're going to accidentally forget. There's going to be people that do it, maybe even people today, but they're going to say 4 times 2 and they're going to put 8. Make sure you're squaring that number. Make sure this is an exponent. no, we can all solve that. Divide by 2. My final answer is x equals 8. And again, today we don't have to check anything. That's our answer. We feel confident. We didn't make a mistake. We move on. Next one. Square root 3x minus 1 equals 10. It's a radical by itself. Yeah, radical's over here by itself. There's nothing else. Like, we're going to start to see there might be a number in front of it, or we might add a number outside of it. But right now, the radical's by itself. So, Bree, what exponent do you think I want? What's the index? No, it's not there. What index is in there? 2. So I'm going to use an exponent of 2. So I'm going to square both sides. So again, you just get the radicand, just what's underneath. So 3x minus 1. Square this, so 100. Now hopefully it's a pretty basic equation. So we're going to add 1. 3x equals 101. Well, we're going to find not everything works out nice and neat. This is going to be a fraction. We can leave it as 101 over 3. Or what is that? 2/3?
Yeah.
I think it's 33 and 2/3. Yeah. So either way would be okay. So improper fraction or mixed number, that I don't care. Yeah.
So since you said the index is 2, and then we go outside of it to multiply, to do, yeah. put
A
the two together.
power. Mm-hmm.
Yeah, so if the index is 3, does that change it to?
Yep, and we're going to see some. So if this had been even a 5, then our exponent, our power, would be 5.
So just whatever the index is, we're going to use that.
That will be our exponent. Yep. And we'll see some as we progress through. Here's the next one. Negative 2 square root of x plus 4 equals negative 20. So now we're getting to some where it's not just the radical by itself. So we're going to have to get the radical by itself first. Jordan. All right, so we got to get the radical by itself. Kelton, what do you think we do first? Yeah, so just picture this as an x. Don't worry about the radical. We're just solving an equation. So we do the addition and subtraction first usually. So negative 2 square root of x equals negative 24. Eva, what do you want to do next? Yep. Question, Alex?
Yeah. Is that square root of x can attach to the negative 2?
So attached in the sense that there's multiplication in between them. So not, I don't know what you mean by attached, I guess. There is a sign in between them. There is multiplication. So that's why now I'm going to divide.
Okay, that's awesome.
So if you
So that
just
answers-
pretend that radical is just an x or a y, you know, you would know, oh, I gotta divide by 2 and put it on each side. So that, it doesn't change, just pretend that it's a.
Just pretend the radical isn't there for a moment. So we get the square root of x is equal to, now it becomes positive 12. Oh, Ridge, what should I do next? Yep, so it's a square root. So I'm going to square both sides. And you're going to have a lot of them that are just square roots today. So I'm going to square a lot. What's 12 squared? 144. Oh, and that was just x already. So I don't have to do any solving after the fact. Okay, so here's one where we have a cube root. So we have the cube root of 2x plus 7 equals 3. Not sure why I put so much space there. Jordan, do I need to have you stand? So I've got the radical is by itself. So we're ready to get rid of it. Xavier, what do you think I'm going to do to get rid of it? Yeah, It's a cube root, so let's cube both sides. That means using that power of 3 on both sides. So the cube root and the cube cancel each other out. So the index and the exponent have to match. So I get 2x plus 7 equals, again, with the 3 and 3 particularly, I see people put 9. No, 27.
I just put 9.
Yeah, 3 and 3 is a common one. And now, we'll solve that. So subtract 7. 2x equals 20. Divide by 2. X equals 10. So hopefully these don't seem too bad today. Let's try this one. Cube root of x minus 9 equals negative 1. Price, what do you want to do first?
Add the 9.
You gotta get the radical by itself. So we're gonna get the cube root of x equals 8. Chandler, what do you want to do next? Not the cube root, but cube it. Is this what you want? That's what you want to say, I'm guessing. I'm hoping. So we're going to cube each side. Anyone remember what 8 cubed is? Not 64. 512.
64 times 8. Close. Just need one more times 8.
And I think some of them had already used their calculator, so. I don't know how many still have perfect cubes memorized. Does anyone have 9 cubed memorized still? This does start with 7.
729.
729. It's good teamwork.
Boom.
See, I don't think they had 512 memorized. How about 6 cubed?
343.
No, that's 7 cubed. 216. Did you cheat?
This is honest.
Alright, let's look at this one. Square root. What are you doing over there with those? Bridge. Huh?
Just say
I am worried about it because it's bothering me.
I took the sticker off.
Okay, well, leave them alone. It's distracting me. If nothing else. I can't help it. Square root of x minus 25 plus 3 equals 8. Maddie, what do you want to do first?
Subtract 3.
So really, I hope you feel like this is just kind of like basic solving of equations with this one additional step right here. Jerica, how do I get rid of that radical? Not this time. Square, because the index is 2. So you just got to pay attention to that index. When it's on our paper, it's a little bit easier. So x minus 25 equals 4. Now add the 25. X equals 29. Let's see how many more I had. Let's do this one. Then we'll call it good. You can start your homework. I've got 2. 5th root of x plus 5 equals 6. So we haven't seen this happen yet. 2 5th root of x plus 5 equals 6. Kelton, what do you want to do first? Yep. So 2 5th root of x equals 1. Jordan, what do you want to do next? Yeah, so again, this is just multiplication out here, so divide by 2. So the 5th root of x equals 1/2. So we hadn't seen a fraction over here. It's not going to be a big deal. Ridge, how do you want to get rid of that radical? So you're going to use an exponent of 5. So you're right, we can't say squared or cubed for this one, so we just say an exponent of 5 or raise each side to the power of 5. And so those cancel. You have your calculators. Put it in your calculator. You don't have to panic when it's a fraction. Should be 1/32. You better not give me what? You better not give me a decimal. At this point in the year, if you were to give me a decimal, the nasty note I would write on your paper.
I don't know. I don't wanna see what that note is.
Well, you try it, Isaiah.
That's
Let's
what I'm
see how
saying.
it works for you.
So what I,
Challenge.
so I said, what we're hearing is give a decimal.
Yeah, you try it. Let's see what happens. You're this close to the end. I'd hate for it to ruin your graduation.
I would hate for there to be a decimal.
All right, there's your homework. You got about 10 minutes to start. Page 456. You're doing 3 through 19. You get a pretty good start on those. Page 456, 3 through 19.
Yeah, you know what I forgot today?
Your headphones.
Freaking headphones.